Welcome everyone. I'm just going to give a brief introduction. So my name is Ian Marcara, and I'm the chair of the Department of Cell and Developmental Biology in the Vanderbilt School of Medicine. And I'm a member of the Vanderbilt Ingram Cancer Center. So my research group investigates how the growth and organization of tissues in the body are regulated and how this regulation is disrupted in cancer. And I've also attended conferences on evolution and the origin of life, so I'm quite excited to be participating in this discussion. So I really feel today's topic, which concerns how life began on Earth, is really one of the most interesting and fundamental questions humanity can ask as we try to understand our place in the universe. The Nobel laureate, Jack Szostak, calls this question about the origin of life a problem in chemistry. But we're pleased today to bring together faculty with diverse expertise to discuss the concept of origins of life from a variety of perspectives. I think one difficulty with this type of discussion is to come up with something as seemingly simple as a satisfying definition for life. For instance, is this definition just based on chemistry or biology? Or do non-mechanistic considerations like purpose play into it? Do science and religion conflict in this space? And how do we think about synthetic or virtual life? So today we're going to delve into all of these topics and more, and I'm excited to see where the conversation goes. So just a housekeeping note, we'll begin with introductions from the panel and then a moderated discussion. And then we'll address questions that were pre-submitted by registrants. And any of you that want to ask questions during the session, if you have questions, you can put them into the Q&A, which is at the bottom of your Zoom screen, and then we'll try to get to them. So I'll now ask our panelists for a brief introduction. So Ellen, would you like to go first?
Sure, thanks Ian, happy to. Delighted to be here and looking forward to the conversation too. I am the theologian in the room, Christian theologian, and I work on issues particularly around gender, sexuality, race, and so on, disability, etc. I'm also working now currently on a book on social media. It's called Seeing and Believing, Theology, Visual Culture, and the New Media. So I'm also very interested in thinking pretty actively at this point about issues around the virtual and how it connects to the so-called real life. So I'm excited about all these different dimensions of our conversation today. And I will turn it over to Stephen.
Thanks, Ellen, and thanks to everyone for attending. And I'm really looking forward to this conversation. I'm an assistant professor in the Department of Physics and Astronomy, so I'm the astronomer in the room here. I come to Vanderbilt by way of NASA's Jet Propulsion Laboratory, Caltech, and as you can probably guess from the accent, from the UK, Cambridge University and Oxford University. My research group here focuses on this new era of trying to do astronomy with gravitational waves. So this is not conventional astronomy of looking through telescopes for having probes that look in the electromagnetic spectrum, but searching for gravitational waves emitted by colliding black holes and neutron stars. So this is a different way of doing astronomy by almost listening to the universe and the sort of tremors in space-time that can help us unlock some of the dark compact objects out there and say something new about the universe. And I'll pass it over to Len then.
Thank you. I'm Len Goodman. I teach philosophy at Vanderbilt. I've been here since '94, and I've been teaching philosophy since 1968. I'm very interested in biophilosophy. I also am a specialist in Jewish philosophy and Islamic philosophy. In Islamic philosophy, I'm an interpreter, and in Jewish philosophy, I'm more of a player as well as an interpreter. I've written a book about the nature of evolution and the dialogue between evolutionary biology and religious philosophy. I don't see evolution and religion as competing or conflicting with one another. I think that they complement one another in very constructive and interesting ways, which somewhat get obscured by turf battles, territorial wars between people who are scientific, but not necessarily scientists, and people who are using religion for political reasons rather than for deep theological commitments. Who do I pass it to?
Okay, I guess back to me, I guess. Thank you, Len. Thank all of you. So perhaps we could begin the conversation. I'd like to ask all of you what the concept of the origin of life means to you, each in your specific fields, and what from your perspective do we mean by life? So maybe Stephen, we could start with you, and then Len and Ellen. So.
Yeah, sure. In astronomy, the concept of life and the origin of life is linked to two main signatures: biosignatures and techno signatures. Biosignatures are really trying to look for any form of life, not necessarily intelligent life. By biosignatures, we mean trying to look at the atmospheres of exoplanets, planets around other stars, and infer whether there are any gases or chemical signatures that would not be produced naturally. For example, we look for potentially excess methane. Methane is a metabolic process. It's given off by metabolic processes. We're encouraged by the excess of methane in Earth's atmosphere and the fact that various photochemical processes can break it down. So any continued level of methane in an atmosphere could be a telltale sign of life. Now, not necessarily intelligent life. There are other more speculative signatures for intelligent life, and those would be the techno signatures. Things like, well, if there are mega scale astroengineering projects conducted by civilizations out there, some of those could be Dyson spheres, really structures that encapsulate an entire civilization star so that they can harness all of that. And believe it or not, we have actually searched for Dyson spheres in data by potentially looking for excess infrared radiation from certain directions. There are other types of mega scale astroengineering projects. One of them would be a giant solar sail that would be the size of a solar system and effectively propel an entire solar system across the galaxy at a very, very slow speed. But nevertheless, it is something that could be a signature of a very intelligent civilization. And there are some rough levels of civilizations that have been proposed, something called the Kardashev scale. A type 1 civilization on the Kardashev scale would be a civilization that can harness all of the star's energy that falls onto their planet's surface. So we're not even a type 1 civilization. We're somewhere between type 0.7 and type 1. A type 2 civilization would harness all of the entire energy of their star in the entire solar system. And type 3 civilizations would harness the entire energy output in their galaxy. And there are propositions even beyond that. So we're very low on the rung of what's being proposed as intelligent civilizations. For life, going back to the original question, we look for these chemical processes in exoplanet atmospheres. And that's our best way at the moment of trying to see if there are the building blocks and processes for some form of life occurring.
Thank you very much. So, Len, I think you perhaps have a slightly different view of this.
Well, yes, I don't have any evidence about civilizations that harness the whole energy of a galaxy or even a star. We'll leave that to our friends in astronomy. Astronomy is a very interesting area. If you look back in the 20th century history of astronomy, there were two big hypotheses about where the universe came from. Fred Hoyle had a steady state view that it's always been and there's new matter always being created. And that was his way of explaining the redshift in the spectral analysis of distant stars, indicating that they were receding at an enormous rate and thus the universe was expanding. The Fred Hoyle's approach, I actually heard him speak about it, was ultimately not confirmed. Nowadays, we tend to believe in that the redshift is explained by an expansion caused by an initial singularity in the universe. Things really did have a beginning. The medieval philosophers would have given their eye teeth to be able to have evidence of that. They didn't think it was possible. They differed about whether there was a first moment of time or not. And if they had known that it was possible to show that, that would have been a very exciting moment for them. Fred Hoyle had an interesting idea about the origin of life on Earth. He thought it came from elsewhere via asteroids or meteorites and so forth. From the philosophical point of view, that really pushes back the question about the origin of life. Okay, so it came from elsewhere, but how did it originate? We want to know about beginnings, not just transportation. And that's a question that has been addressed, I think, most prominently by a Soviet scientist named Oparin. He and JBS Haldane both had theories that that there was a kind of soup in an anaerobic atmosphere, in an oxygen poor reducing atmosphere, and energy, perhaps in the form of lightning or some such source of energy, got these particles to form more and more complex structures, which ultimately evolved in the form of life. What interests me most about that kind of mechanistic explanation of the origin of life is the way it begged certain questions. It assumed that the origin has to be mechanical, and in order to press that point, it was really arguing against a somewhat mystical view of the nature of life, which was labeled vitalism or some such term. And I think nowadays vitalism has not got very many advocates to it. And I think that the notion that vitalism is sidelined or refuted has been used to press a reductionistic and mechanistic view of life, which overlooks some of the most important notions in those origin stories. The key notion, in my view, is the notion of emergence. We see in astronomy that stars, quote unquote, cook hydrogen to form more complex elements. We see the elements in systems like our solar system forming more and more complex chemistries. The idea of the emergence of complexity and the values that are represented in that emergence, starting with something like stability and going on to something like reproduction, going on to something like adaptation, going on to something like adaptability, and adaptability becoming less and less a matter of genetic adaptability like we see in our viruses and our bacteria, and more a matter of learning like we see in living beings. We see that emergence itself emerges. The willingness of mechanists to overlook the idea of purpose and the emergence of purpose and the growth of autonomy as a value in nature is something that has been quite a deficit in the growth of sciences. And I have great hopes that scientists will overcome their allergy to the idea of purpose and look back to some of the classical philosophers like Aristotle, who thought that there are lots of different kinds of causes. Mechanical causes are important among them, but so are desires and the emergent notions of value that beings themselves can generate.
Thank you. I think it's very, very interesting. Ellen, would you like to comment on what your view of origin of life is?
Sure. To me, the most interesting question about the origin of life, and I think the one that theology is perhaps best prepared to answer and to wrestle with, is really about the why, and to a certain extent about the what. And so those are the questions that I think are particularly interesting to me. And I think of life primarily as, my definition of it, I think, would have to be really vitality. And I would want that choose vitality as the definition, in part because of a lot of what you've heard already from Len and from Stephen. That is, wherever we find ourselves on the spectrum of life, we might say, that kind of propulsive, emergent, energetic, whatever, movement, I guess, is kind of what I think is really important about and helpful in the way that we think about life, partly because it avoids the too harsh a distinction between organic and inorganic life, we might say, and between forms of life, whether within organic and inorganic. One of my very favorite cartoons ever, it was in the New Yorker. I don't know if you all know it. You may recognize it. It's of two balding, slightly obese, older white men on the sitting on the back of their yacht, or one of them's yacht. And the yacht is called the Hi-De-Ho. And they are being waited on by these lovely, buxom young women. And one says to the other, not bad for someone who shares 98% of their DNA with the common flatworm. I think that's a really fabulous kind of metaphor for reminding us that not only that vitality is the thing that keeps us, that joins us together, but also that that there is much more that unites us, in a sense, all these different forms of life, than that divides us. And and while human beings certainly are pretty unique in terms of what we bring to life and to the study of life and what we can learn and what we can articulate, we are by no means completely unique. And we are not only completely and totally dependent on all the other forms of life that we are surrounded by, but we also, for that reason, I think, hold a particular responsibility in relation to all those different forms of life. And that, to me, again, comes back to the why and the how, and what it is, where does that responsibility originate, I guess we might say, and how do we understand that from, and how can theology help us understand what that responsibility is, and where it comes from. And those are the kinds of things I think that as a Christian theologian, I'm particularly prepared to answer. And I can also, of course, speak to the issues of conflicts, supposed conflicts between science and religion too. So, but that, I think, is where I'd start.
That's great. Yeah, I have some questions listed here that I think I'd be very interested to get your take on. So I was going to ask a question sort of related to Stephen's comments earlier, about biosignatures and stuff, and really the questions about how common you think life is in the universe. And I just want to remind people, I always think it's absolutely mind-boggling to consider that there are more stars in the universe than there are all the grains of sand on every beach, every country on Earth. You just pick up one handful of sand and you think how many thousands and thousands of grains of sand there are in that handful, and then how much there's on one beach, and then all the thousands of miles of beaches, and there's still, that number is smaller than the number of stars in the universe. And most of those stars, we think now, have planets around them, and many of those planets are going to be rocky planets. And I think the other point, very interesting, is that many of the basic molecules from which we are composed, things like methane, that Stephen mentioned, but other things that are essential components of our bodies, are present in molecular clouds throughout the universe. And in meteorites, there are carboniferous meteorites that contain hugely complex organic compounds. So from a biological point of view, I think this is very interesting. But I would like to get some ideas from you guys about this and what it would mean. What does it mean to a theologian, for instance, if there are a trillion planets out there that have life on them, and maybe some of them have life very much like ours, and some may be very different. So maybe, Ellen, I could start with you and then go to Stephen and Len for their takes on this.
Yeah, I think that's a fascinating question, Ian. And it's one of the reasons why I think it's important to think about life in as expansive a way as we can. And, you know, one of the things that's been true, certainly of the history of Christian theology, at least, is that for, you know, for most of its 2,000-year history, it's really been kind of focused on life on Earth and not really thinking about life in this more expansive way. But I think there are most definitely ways for Christian theology to think much more broadly about life, and I think there's a real lesson to be learned, first of all, from just exactly what you're describing. You know, the thousands of grains of sand, and there are more stars out there than anything. That should make us very humble when it comes to any kind of pronouncement about, you know, about life and about its origins and so on. And it would also, and it seems to me to be very much in keeping with, I mean, oftentimes this question about whether science and religion are compatible comes down to how we think about God, right? And it would push us to then think in much more expansive ways about divinity and about what we mean by that, and about God and God's role in creation, and also would push us to think about creation differently, that it wasn't a one-time event, right? But that instead it is an ongoing event, and it hasn't, and there's no telling when it will stop. There's no telling what its, you know, what its limits are, what its reach is. And I think, again, there are ways of thinking about divinity that accord very well with that kind of idea. That may be, you know, not the typical way that we think about God, which is basically kind of as a big, giant, bigger human being than us, smarter than us, et cetera. The smarter stuff, yes, I would want to hang on to that. But I'd also want to keep a role in play for what has also been a very traditional notion in Christian theology, and that is the idea of divine mystery and the idea of divine transcendence, that there is a radical difference between the divine and us, and the divine and all kinds of life that we know. But that radical transcendence is not a complete separation, but instead, you know, a distinctive role, we might say.
Len, do you want to add a few words?
Yes, I think when we think about what Ellen is talking about, very rich, to think about at once the smallness of the place we occupy in the universe, and the vastness of the universe, and the vast complexity of the human mind and the human brain, which has evolved and brought us to this place. We are at once humbled and proud, able to recognize a kind of uniqueness which is in each individual, which is something sacred, is something precious, and at the same time a commonality, as Helen was saying, with the simplest living being, which isn't all that simple, and the little dynamics of molecules and electrons. You know, it used to be thought that that matter was kind of dead and lifeless. Turns out it takes a lot of energy just to get it to stop moving. Inertia turns out not to be just a matter of inability to move, but also inability to stop. And that discovery is part of what marked the origin of the modern age and the beginning of science, with the work of Galileo and Copernicus and others who learned. Medievals were impressed with the vastness of the universe, but they had no idea how vast it really is. They were way off by many high order factors. But within that vastness, we have a special place. And picking up on what Ellen said, we have to recognize that other beings have a special place too. One of the things that I think is important in terms of ethics is to recognize that what we have to regard and consider sacred and special are other persons. And I make that point specifically with reference not just to other humans, which are very special, but maybe persons that don't look like us at all. If they're subjects, if they have moral capabilities, if they have an awareness of the world around them, regardless of the physical form they take, they're persons too, because they are subjects, because they have moral regard. We have to start thinking in much broader terms when we look at things in that cosmic scale. So I think there are ethical implications even to this question of size and diversity of life on our planet and of life on the many planets we now suspect may harbor life elsewhere.
Thank you. Stephen, as an astronomer, what do you think about sort of the commonality or rareness of life throughout the universe?
Yeah, I'm really glad that that all of you were able to speak to the sheer size of the universe, because we live in one galaxy that has roughly 800 billion stars, many of which like our own, and the observable universe has somewhere like 2 trillion of those galaxies. So by sheer statistics, it's unlikely that we're alone in the universe, to at least, given some form of life, especially since life on Earth seemed to start developing very early in the lifetime of the Earth. It didn't seem to have been that hard for life to kick off on this planet. And when thinking about how common life could be, there are some sort of instructive, what we would call back of the envelope calculations you can do. And many people here might have heard of the Drake equation developed by the astronomer Frank Drake. And it essentially compounds the different probabilities of phenomena occurring in order to generate life, and in this case, intelligent life that we could communicate with. So when considering the number of civilizations in the galaxy that we could potentially communicate with, you take the rate of star formation in our galaxy, then you take the sort of chance that planets will form around those stars, the number of stars that could harbor some sort of chemical processes that could generate life, then the chance that of those planets that intelligent life does actually develop, and that the civilization that forms sticks around long enough in order to communicate with us or send out some sort of signal. And it can vary hugely. So I can't give you a solid answer apart from just kind of resorting to statistics. It can vary enormously. There are numbers that put us alone as an intelligent species in the Milky Way, and there are numbers that say that there are hundreds of thousands of potentially communicable civilizations. And that's really the key, because even if we're not alone, and even if intelligent civilizations or some form of life develops elsewhere in the Milky Way, it might not matter because we can't communicate with them. We're limited by the speed of light for communication, and we're limited by some form of propulsion system if we want to actually go there. The propulsion is the real bottleneck, because even at our top speed with propulsion at the moment, it would take thousands of years to reach the next star over. So, there are numbers that vary by many orders of magnitude, many factors of 10. But an honest question you could ask, given the sheer size of the universe, is why hasn't some really, really advanced civilization contacted us by now? And that's kind of enshrined within a paradox known as the Fermi Paradox, or the Great Silence. Why has a really advanced civilization not tried to get in touch with us? There are a couple of possibilities, and they're linked to that Drake equation, to several of those factors that feature in the Drake equation. It's possible that many civilizations don't mature enough to avoid destroying themselves, making themselves extinct, before they can explore the stars or at least communicate with us. That could be a source of the Great Silence. Another possibility is that such civilizations that do develop and start exploring the stars have their own form of what in Star Trek they would call the prime directive, that there's non-interference with us as a primitive civilization, or civilizations have realized that it's better to keep quiet and stick to their local neighborhood, because as human history tells us, whenever quote unquote more developed civilization comes in contact with a less developed civilization, tragedies ensue. So those are some possibilities to explain the Fermi Paradox and the so-called great filter, why intelligent civilizations can't get through some sort of bottleneck or barrier to start talking to us. So there could be many civilizations. Some may choose not to speak to us. Some we may not be able to contact at all. And some we may not even understand if they tried to contact us. As Len and Ellen were discussing, there could be a huge variety in the morphology and maybe conscious thought processes of different civilizations. And you know, we shouldn't think, again, that it's going to be like Star Trek, where limited television budgets restrict aliens to looking like humans, but with some prosthetics on. They might be vastly different and might think in completely different ways, and their own morals and ethics, thought processes will be shaped by conditions on their planet and in their history. So in some ways, the movie Arrival is a better demonstration of that kind of interaction happening.
You know, I always think that we've done such a poor job of communicating with other sentient species on our own planet. I mean, there are crows and chimpanzees and, you know, many species that actually are clearly conscious. And some, like elephants, are self-conscious. They can recognize reflections of themselves. And yet, you know, we can't communicate with them, or very poorly. And so I wonder, you know, and really they're very similar to us. As Ellen said, you know, they're 90% identical in terms of the information within their DNA. And so now you have some alien civilization that has no connection to us whatsoever. And you think, yeah, how on earth would one begin to communicate?
Yeah, actually, I mean, jumping off that really quickly, I think if I get the reference wrong, then hopefully Ellen or Len can correct me. But I think it was the philosopher Wittgenstein who said that even if there was some way to communicate with a lion or a tiger, you know, some sort of universal translator, then you would still not be able to have a conversation, because the frames of reference of their lives are so different. So so having a common language is not the choke point. It's having some sort of commonality of reference.
I think that's true. I'm remembering a remark that the late young philosopher Bob Solomon made. He was writing about the emotions, and somebody raised the question of what about coitus between species, and he said that he thought like trying to make love to an animal of a different species would be like trying to discuss Spinoza with a snail. The snail's interests are really not where ours lie. I'd like to pick up on another point, however, with regard to the question about the origin of life, and I'm sure many of those who are registrants are concerned with this. We all know there's an old example about if you put a bunch of monkeys in a room and have them sitting at typewriters, give them enough time and enough paper to put in the typewriter or memory to put in the computer, they would eventually come up with the works of Shakespeare or something like that. What that kind of example brings up, and it's a very old example. Originally, it was a Stoic example about putting brass letters in a barrel and shaking them up. They didn't have typewriters in those days. But what the example was supposed to show was that giving world enough and time, you could generate just about anything. And the problem with that line of argument is that generating just about anything does not necessarily give you any way of generating life. What distinguishes life in any form from non-life is the idea of purpose. There's a directionality, and the directionality itself is emergent and evolving as life emerges and evolves. So there has to be a value to stability, there has to be a value to adaptability, and so forth. And there has to be something that would count as what matters. I think that that's the dimension that most concerns those philosophers and theologians who look to a higher purpose than mere mechanism. The famous example that William Paley gave about finding a watch on the heath. You're out there walking in the wilds of England, such as they are, and you find a watch, and you know it didn't just pop up like a daffodil there. It must be somebody's watch. Think about it a step further. If you were walking on the beach or on the heath and you found a cell phone, you wouldn't think that just washed up with the waves like a clamshell. It's somebody's cell phone. You'd look at it and try to figure out, if you could, whose it was and where it came from. You'd try to operate it and see how it works and whether there's any identifying information in it. The thing that I think is most interesting, if you go back to the 20s when Oparin was operating and pushing Lysenko down the throats of his fellow Soviet citizens, the thing that matters most about life is not whether you're a vitalist or a mechanist. The thing that matters most about life is that life contains value, pursues value, and is oriented towards that. Teilhard de Chardin, who was in his heyday as a paleontologist around the same time that Oparin was working, spoke in a metaphor about groping. He said that matter has this, what you could metaphorically call an interest. It's sort of looking around and trying to find its way. And it doesn't know in advance what its way is going to be. Biologists consider it heretical to talk about orthogenesis as though evolution knew that it was reaching for perfection. Evolution doesn't know where perfection is or what perfection is, but it's always probing different avenues. And the thread that Teilhard de Chardin pointed out leads you through the labyrinth of biological diversity is the thread of the quest for autonomy, the quest for understanding and intelligence. And it reaches a limit, for example, in insects, because they have an exoskeleton and that makes them too heavy to get their brains big enough. So all their complex development has to be at the social level rather than individual level. That's why ants and termites are the way they are. That's a fascinating thought. And it gives you the idea that if evolution didn't point at us, it was in that curious groping way, looking for something that might look like us or might look quite different, but could be the kind of higher intelligence that Stephen was addressing. Maybe far more intelligent, maybe far different from our own kind, but worthy of value.
Thank you. Actually, I'd just like to go back to something Stephen mentioned, was how early life began on the Earth, which was not a nice place back then. So the Earth was formed about 4.8 billion years ago. And the first billion years is wiped out because of plate tectonics. So we have no idea what was happening, really. But life, as soon as we could detect it, within 3.45 billion years ago, there's microorganisms there. And so you think, yes, it's not really like monkeys typing Shakespeare, because you start small and you build,
Yes.
Rather than creating a whole book, you start creating words first. Or you create letters, and then you create words, and then you create sentences. But I do think, I think it's an interesting point that suggests that given the commonality of the chemicals that were on the Earth, and the amount, I think the problem with understanding this is the amount of time, millions and millions and millions of years when all of this stew of chemicals was sloshing around on the Earth, and trillions of tons of it. So this is, I think, why it's a very difficult problem for us. All we can do is look for plausible chemistry that could have happened, but we can't really reproduce what happened on the Earth because it would take a whole planet's worth of stuff and millions of years probably, right? But still, in the whole scheme of things, it could happen relatively quickly.
But it's an accelerating process, isn't it?
Sorry,
Yeah.
yes.
It's an accelerating process.
Yes,
And,
it's an accelerating.
like the evolution of technology, for example. Once you have metals, you can do more with them, and it sort of snowballs, whether you're talking about evolution or you're talking about invention.
And I think I think this is to do with copying information. Right? I mean, that was the key invention, I guess, if you can call it an invention, was the creating information in a molecule that could then be copied. And it's just like now. I mean, our technology accelerates so fast because we can store information, and so we can pass it on from generation to generation.
Look at viruses. Viruses can't. They have to pirate. They have to pirate the genetic ability to reproduce, but other living beings can.
I think this question of purpose too, though, is a really interesting one and a complicated one to think about too, again, from a theological perspective as well. And one of the contemporary forms of theology that I think is particularly interesting to think with and think about is one that deliberately tries to engage science and is thinking about thinking in a certain way from a scientific and theological perspective at the same time. And it's a movement called process theology that originated as a form of philosophy. Charles Hartshorne was its parent, if you will, in the philosophical world. And he was trying to, he's doing this, in the 40s and 50s. So it's relatively early quantum physics, but trying to put together a way of thinking about life and thinking about life from a philosophical perspective that was compatible with and built on some of the insights of quantum physics. And it became very interesting to theologians who were also trying to do something similar, because it had embedded in it this idea of this kind of multiplication, replication, all that kind of thing going on as constitutive of life. And so this possibility of a vast expansion that, maybe started somewhere kind of small, but then it just keeps going and going and going and going. And in a way that allowed for thinking differently about God and about this divine, about purpose in all of this. And for the theologians who adopted it, they came up with this, what they called panentheism, which is that all is in God and God is in all, and that God is in some sense the source of this creative, generative movement, explosion, however you want to think about it, by generating all kinds of possibilities. And then also all kinds of possibilities at every level, from the tiniest, microscopic level, tiniest little, subatomic particle, tiniest cell, et cetera, to the most complicated entities we know of and can think of. And God is not only generating these multiple possibilities, but also has in mind, if you will, what the best ultimate outcome of all of these possibilities would be, and is luring at every level, luring the creation toward those possibilities. But at every level, there is absolute utter freedom, and there is no guarantee at all that any of these particular generative possibilities are going to be adopted, whether we're talking about ants or whether we're talking about viruses or whether we're talking about molecules or whether we're talking about human beings, right? And so God has constantly having to reinvent the wheel, so to speak, right, to generate more possibilities. And there is this, I think, lovely kind of way of thinking about how all of life is connected, and also how it's connected, not just in terms of the dynamics of life, but also even in terms of the purpose of life. And that's not any easy thing to navigate or negotiate, right? Because there are going to be conflicts what a virus wants to do, right, is one thing, and we don't want it to do what it's doing, right? So we want to fight that virus as much as we can. And yet when we do that, it has unintended consequences that we then have to respond to, right? So, so I think there's a really rich way of thinking that I think engaging religion and science together helps us think, particularly when a theologian's going to be a little bit less reluctant to bring in giant schemes about purpose, right? To think about that than a scientist would be, and rightly so, right? And because you don't want that to interfere with how you see what's happening. If you've got some normative idea about what should happen, right? But I think that can be a really generative point of convergence and conversation that can take all kinds of different forms too.
Let me pick up on what Ellen is saying here.
Okay. Short, keep it short though, Len, because we've only got 10 minutes left, and I want to switch to questions from the panel.
Historical footnote: Charles Hartshorne was one of the four main disciples of Alfred North Whitehead, who collaborated with Bertrand Russell on the formalization of logic. And Hartshorne was probably the most religious of the four main disciples of Whitehead. But Whitehead was the inventor of what was called process philosophy. And one of the interesting things, I'll keep that very short, about Hartshorne is that part of his religious sensibility is expressed in his fascination with bird watching. He was very interested in bird song, and he thought, and I think this is terribly important for those who are interested in the nature of life, he thought that birds sing. We know that birds sing to declare their territory and to retain a mate and to attract a mate and to keep other birds away and so forth. But Hartshorne also believed that birds sing because they enjoy it, that they enjoy singing, that they develop skills at doing it, that they're judged by prospective mates in terms of doing it. One of the things that Hartshorne did in that dimension of his work, which was a big dimension in his life, was to look at life from the point of view of those who are doing the living, rather than just putting them on a plate and dissecting them, trying to look at it from their point of view. And that, I think, is very important for all of us to be able to do.
Okay. Yeah, thank you. I'm going to, because we've only got about 10 minutes left, I'm going to take some questions that were put into the Q&A or were pre-submitted. So there's one here from Michael Zargari, and he has two questions, one for Stephen and one for Len. And Stephen's is going back to, alien civilizations sort of stuff. So he says, Congress has recently released radar recordings of multiple unidentified flying objects, along with a report stating they don't have an explanation for them. Do you believe this is evidence, in quotes, of advanced aerospace technology that supersedes current human capabilities, or is simply an artifact from our radar technology?
That's an interesting question. So the statement was, Congress is not sure what these things are. I'm sure there are lots of things that Congress doesn't know. But whether that's evidence of advanced aerospace engineering, it could be another country on Earth that is experimenting with advanced flight technologies. It could be natural phenomena that we haven't characterized yet. They're so rare on Earth that we don't know what they are. It's really difficult to say. And in my personal opinion, if a civilization is advanced enough to come and visit us, then surely they're advanced enough to cloak their presence on Earth, and they're not going to be observed in any way by us as primitive beings. So it's a tough question to answer. I think we'll just have to wait and see, and it won't be answered within our lifetimes. It might be a generational thing where we get more or some form of evidence over for thousands of years until we develop enough that they may be more interested in contacting us in a fruitful way.
Thanks. Okay, there's another part of this question. Well, it's a different question for Len and maybe for Ellen as well. How do you reconcile a religious conception of humanity as being sort of at the center of the universe with the potential of infinite advanced civilizations?
First of all, that's a bit of a stereotype, and as a philosopher, I'm always a little allergic to stereotypes. I study medieval texts firsthand and ancient texts as well. Believe me, dear questioner, the notion that medievals thought we were at the center and therefore in the top spot in the universe is simply incorrect. Many of them thought we were in the bowels of this creature and in the bottom of the universe, and we needed to know our humility and our place relative to far greater beings, which included, for example, the stars, which were thought to be intelligent and permanent and in charge of what happens on Earth. Watch out for stereotypes and sort of vulgarizations of what religious people think. Religious people vary just as much as other people do. Please, Ellen.
Yeah, and I just want to add. So let's if we go back to one of the things that's really interesting to do is to think about the book of Genesis, and particularly the creation stories in Genesis. Now, first of all, you probably think that there's just one, but there's not. There's at least two, right? And particularly in those first two chapters. And both of those creation stories, as different as they are, I think don't give rise to the idea of everything being all about the human being at all. So the first one is very much at pains to talk about the creation of everything, starting with the separation of light from darkness and, water from earth and all of that. And then, yes, the human being is the last thing, and God says at the end that it is all good, right? It is all good. And then particularly the second story, which is the story we think of as the story of Adam and Eve, right? You think Adam it's a very different model of creation. Instead of God speaking everything into being, God actually literally with God's hands is making everything, right, out of dirt. And we think about Adam as a proper name, but it's actually a pun. It's a pun on dust, which is Adamah, right? So God creates Adam out of dust, right? And so the better way to translate Adam would be earth creature, really, or dust creature, right? And again, it's all about the connection, the interconnection between all of these creatures. So, God creates all these other things and shows them to Adam, this earth creature, to see whether or not, is this the helpmate that's going to work for you? No, not that one, and so on and so forth, right? But all of that is just the fact that the creation in that second story happens in a very earthly way at a very specific location, kind of where the Tigris and Euphrates meet in a certain way, right? In the Garden of Eden. And that it results in this just lush, luxurious, garden where Adam and Eve, which is basically mother of all living, had everything available, right? Where there was just a real richness of life, and where all of their needs were met, all the needs of everything were met. And that, I think, again, decenters that idea, and in the way that goes back to the ancient scriptures that Christianity, Judaism, take as sacred, that really puts us in our proper place, if I might say, right? And that proper place is as a part of a larger created order, not as its dominant,
By the way, the same play on words occurs in English, because homo, the word for humanity, also is cognate with humus, the soil, the dirt that the gardener has to cultivate. We are creatures of the earth in both of those cultures.
I haven't realized that. That's very interesting.
Related to the word humility, by the way, which is a good point for all of us to recall.
Right. Okay, we're getting to the end. There's another question in the Q&A from Maria Campitelli asking, where did the first energy for the origin of life come from? And I can briefly talk about that, maybe Stephen also. The early Earth was a pretty violent and active place. I mean, there was, of course, this solar energy, which absolutely everything ultimately depends on, but also bombardment, There was massive bombardment by meteorites, probably a lot of which would carry organic materials to the Earth and water from comets and other types of structures hitting the Earth, and lightning. So there was many and radioactive decay, which back early in Earth's history was greater than it is now, and it was heated the interior of the Earth. So I think there's a lot of different sources of energy that were ultimately able to be utilized by the very earliest sort of proto-living things. Stephen, I don't know if you want to add to that? Or?
Sure, I can try to take it back a little bit farther and ask what is the universe made of in terms of its energy content? There are many forms of energy that we haven't characterized yet. The majority of the universe is of a form of energy or material or fluid that we don't know. We call it dark energy. We call it dark energy as a way of putting a name to our ignorance because we don't understand it yet. It's about 75% of the universe. The other 25% of the universe is some form of matter. And of that 25%, only about 4% is what we would call baryonic matter, or when I knock on wood, that's the form of matter we talk about. The rest of it's dark matter. So there are many forms of energy. The origin of energy presumably is the singularity itself and the decay of some sort of initial field in the particles. Beyond that, it gets into pure speculation that we don't understand yet.
And there was a related question that was pre-submitted about what we now think about Carl Sagan's sort of comment that we're all star stuff. And I would say, yes, for sure, but maybe you can say just a couple of sentences about that. Where do all the elements come from that our bodies are composed of?
Yeah, I think Len referred to this earlier, that stars undergo thermonuclear fusion in their cores and convert hydrogen into helium, and then through successive stages of nuclear fusion will burn into heavier elements until you get to about iron. But once you get to iron, it's more difficult to form heavier elements than that. So where does everything else come from? And this was somewhat answered a few years ago by the discovery of the collision of two neutron stars. Neutron stars are highly dense stars, and they were observed colliding with conventional telescopes and then with gravitational waves. And in the aftermath of that, in the spectrum of light that was observed, we see gold and we see platinum and we see heavier elements. So not only are we the result of stellar explosions, we're the result of the detonation of different stars forming these heavy elements. So gold in your jewelry or other precious metals were formed far off in the universe somewhere by the detonation of stars.
Okay, and I think maybe we could finish up with a question that was sort of for Ellen, perhaps, about there's this perceived conflict, right, between religion and science, and I'm sure you get this sort of question a lot, but perhaps you could just address that and say what you feel about it. Maybe it's just a misperception.
Well, I think, yes, it's a great question, and it is out there. I think I'm thinking about the way Len sort of set the stage for that early on and talked about, I think about what is the purpose? Why are we here? And how do we do what we do, right? And I think that what we need to do is to recognize where religion fits in what kinds of questions religion and theology are prepared to answer versus what kinds of questions science is prepared to answer. So, and if religion will be content to stay in its own court, if you will, it brings some things to the table that I think are particularly important. Like I said, the question about why. It's not just how did we get here, but why are we here? And what are we to do with the fact that we're here? Those are the kinds of questions that theology, I think, is best prepared to answer. And if you even think about, so the book, if we go back to Genesis and the creation stories again, that's really their function. It's not so much, trying to explain how we got here, But that question about how we got here, the origin of life, is meant to explain why we're here and why we experience life in the way that we do. So the story of Adam and Eve, right, ends with them getting kicked out of the garden. It's an explanation of why are we, where did sin come from? Where did the fact that we do bad stuff come from, right? Why do people marry? Why is that what we do, right? All those, why is there suffering in the world? Those are the kinds of questions I think that theology is best prepared to address, and can address that in ways that are open to lots of different ways of understanding what life is and exactly how life came about.
Okay, Len, have you got any final words of wisdom for us?
Sure, and I also would take my text from Genesis. It's a great book. It's not a book that's about to be superseded. Partly for the reasons that Ellen was stating. When we see Eve supposedly created from Adam's rib, that's one of the places where the Bible itself tells you what the moral of the story is. It says, Adam recognized that she is flesh of my flesh and bone of my bones. She is not an alien creature. He's been looking around for a counterpart. He couldn't find one. He now finds one. Notice, please, men are not from Mars and women are not from Venus. We're of the same species. We're complementary to one another. We have to help each other. We have to live with each other. We have to look after each other. And the Bible itself draws the moral explicitly. Therefore does a man leave his father and his mother and cleave unto his wife. You might think that your first loyalty is to your family. It's not. It's to the family that you're going to found and form and be loyal to. That's the moral of the story. People who like to try to read the Bible literally often don't read it carefully enough. If they read those things in terms of value and purpose and that broader understanding, they'll get something out of it that does not compete with what science has to say, but complements it in a very important way.
And if I could just conclude with two quick observations about that too. One of the things that happens in the story of Adam and Eve is actually up until that point where Eve is created out of Adam's side, out of the rib, Adam is undifferentiated in every way. And the actual language changes. That's when both male and female emerge. It's not that there was a man before, right? Yeah. But that's when male and female emerge in a certain way. Or it's actually husband and wife is really the term that come up there, not male and female in the way that we think. But still, and then if you could think about also the first story in Genesis that ends with the claim that God created human being, male and female, in God's own image. One of the things I think that is important to think about in terms of how we can interpret that is not, it doesn't say, notice, God created male or female. God created male and female. That allows as well, I think, a more expansive notion of like, in a way of wrestling with the fact that we didn't get into sex and gender, but we'll just make it a quick one here, that that sex and gender are themselves much more diverse than we typically think. And so that has become a particular sticking point. But I think the creation stories give us, again, a much richer way of thinking about these things than one might expect.
And both of them, the language is very explicit. Both of them are created male and female in the image of God. That means the image of God is not a physical image because they don't look alike, but they both share that special relationship with the divine.
Right.
Okay, I think we're running out of time. Stephen, do you have any last words that you want to tell people?
I think it's fantastic that we had this discussion. I learned several things I didn't know, and it's nice to splice together thoughts and discussion about astronomy, astrophysics, the nature of space and time, with theology and an understanding of the origin of life from philosophical and religious viewpoints. So I'm really glad, and thank you so much for inviting me, and thanks for the questions and the attendees as well.
I think we all learned a lot.
I'll just finish up. There was one question which I didn't bring up, but somebody was asking about, well, how really are we going to figure out, you know, the question about how life on Earth began. You know, I would say from a scientific point of view, I think it's a difficult problem. I don't think it's an insuperable problem. I don't think we can do it just in a test tube in a lab, but using computer simulations. As you know, given the advances in computer technology, I think it's perfectly possible that we could come up with plausible explanation. Whether it's the explanation is impossible to tell because we can't look back 4.8 billion years. But we could come up with plausible explanations for how we generated the DNA that encodes the information from which that creates us, and the cells that compartmentalize the materials and the energy processing systems that altogether are necessary to produce a living organism. So thank you all very much. Thank you, Stephen. Thank you, Ellen. Thank you, Len.
Well, thank you.
Thanks
too.
again to Aaron Conley for putting together this really fascinating discussion. Okay.
Thank you, Ian. Thank you,
Thank
Aaron.
you all very much.
Thanks, y'all.
Take care.